All right. On this problem, it says factor. Remember, these are what we call difference of two squares. So 25x to the fourth, if you were to think of that as a square, that would be 5x squared. So you got 5x squared, and for a perfect square of 36, that'd be 6. So factoring that, I'd get 5x squared plus 6 and 5x squared minus 6. Now, sometimes you would break this down further. I probably wouldn't because 5 is not a perfect square. 6 is not a perfect square. I know x squared is, but I would leave it there. But there are some problems, and I don't remember if I had one like this. But like, let's say you had, let's say they said factor x to the fourth minus, let's do 81. So if they had that, I just want to show you because I think you might see a problem like this. That'd be x squared plus 9, x squared minus 9. And now you have two perfect squares again. And for x squared plus 9, that'd be x plus 3 and x minus 3. And for x squared minus 9, that'd be x plus 3, x minus 3. And then one more thing. Remember, if, which it is, if this is a plus, then you also need an I there. So you may see something written like that. And then if they ask you to pick all four factors, you got one there, one there, one there, and one there. All right, this one. There are a lot of terms. I'm going to look for GCF. So I look here, I look at 3, 12. 3 goes into 12. 3 goes into 6. 3 does not go into 8. So never mind there. But on the x's, I got x, 3 x's, 2 x's, 1 x. So what I'm going to do is I'm going to take out 1 x and then write down what's left over. What's left over, so I took out the x. What's left over would be 3x to the third minus 12x squared plus 6x minus 8. And I suppose I could get rid of this. Okay, so I already took out the x. And then from there, you could factor by grouping, but I'm not going to mess with that today. So this is the GCF question. This question, anytime you have 4, 2, and then constant, you can factor it like a quadratic. So first I'm going to look for GCF. I notice that they both have a 2. What's left over? Let's see, that'd be 13. 26 divided by 2 is 13. 24 divided by 2 is 14. All right. And then from here, this is when you'd make your little x. And you're trying to find two numbers that multiply to negative 14, but add to negative 13. What happened there? And so what multiplies to negative 14 adds to negative 13? That'd be negative 14 and 1. So putting all that together, I'd get 2 on the outside. X squared minus 14 and x squared plus 1. Now, x squared minus 14, I'll put this over here to have more space. You could break that up into square roots if you wanted. So you could say that's x plus the square root of 14 minus x minus the square root of 14. I'm going to put a little square root symbol in there. I just didn't feel like drawing out the subject. Square root of 14 and square root of 14. And then for this part, right here, this part, you could factor that into addition of two squares. So that's going to be x plus 1i and x minus 1i. Because x times x is x squared, and 1 times 1 is 1 squared, and when you have a plus, you put an I in there. So just so you can see where this came from, this factors into this. So I have factored the whole thing. All right, this problem, you could use long division or what I call the tic-tac-toe method, or you could recognize that this is actually a perfect cube. And so this factors into 2x to the third, and then that'd be 3 to the third. So then we could use that formula that said that the factor a cubed plus b cubed, that's equal to a plus b a squared minus ab plus b squared. And using that formula, you'll notice that a is 2x, b is 3, so that's where the first part comes from. So that's 2x plus 3. So we know that 2x plus 3 is a factor of 8x to the third plus 27. And then what's left over, I would take a, remember this is a, and that's b. So a squared would be 4x squared, and then minus a times b, 2x times 3 would be 6x, and then b squared, 3 times 3 would be plus 9. So they said take 8x to the third plus 27, divide out the 2x plus 3, so your answer would just be 4x squared minus 6x plus 9. All right. Hence, if the remainder is 0, then it is a factor. If it's not 0, then it's not a factor. And so they want us to take this and see, is it a factor? Now, one way you could do this is technically to be a factor of x plus 8, that means you have an x-intercept of negative 8. So what you could do in theory is type all those into Desmos, and if it has an x-intercept of negative 8, you say yes. If it doesn't have an x-intercept of negative 8, you would say no. And since they're asking for a lot, I'm actually going to do that. And again, the reason why it's minus 8 is because the factor is x plus 8. So let's type all these in. X to the third plus 2x squared minus 48x. X to the third plus 2x squared minus 48x. Look, x-intercept of negative 8, so I'd go here and I'd say, yes, it is a factor. Type that in. X to the third plus 5x squared minus 16x. No. Yeah, we do not have an x-intercept of negative 8. It's right there. That's not an x-intercept, so that'd be a no. Also, if you were to use synthetic, you would get a remainder. Here you do not. 2x to the third plus 20x squared plus 48x. And I forgot what that was. Nope. No x-intercept negative 8. And then 10x to the third plus 110x squared. And what was the other one? Plus 240x. Look, that one is a factor. Now, that's not my, it's really not the best way to do it. That's the way to get around it. The best way to do it would be to use what's called synthetic division. And so you would make your little table, negative 8 would go out here. And I'm actually going to do this one. And so remember, the coefficients have to the third power. I should have 4 boxes. And so I got 1 for x to the third. I got 5 for x squared. I got negative 16 for x, and then there's no constant. You pull down the first number, that's a 1. You take negative 8 times 1, that's negative 8. Add, that's negative 3. Negative 3 times negative 8, that'd be 24. Add those, that'd be 8. And then 8 times negative 8 would be negative 64. Add, and you get negative 64. And so because we have a remainder, you would click this box. But if this was a 0, you would click this box. So that's the difference between being a factor and not a factor.